There are two main types of logarithmic equations. Both of them require us to be pretty proficient with our log properties. So if you haven't watched that video or are still a little bit iffy on the properties, I want you to pause and go back and review those before you start trying to solve any log equations. So before we get started, let's look at an example. Let's say we have the log base 2 of x equals the log base 2 of 5. Let's think about what this says. This says that the power that makes 2x is the same as the power that makes 2 5. So we're looking for something that is the same as something else. If this equation is going to be true, because these bases are the same, these arguments need to be the same. So we can say that x is 5. Those powers are the same. We're still getting 2 into 5. So this is the first example of a log equation. This is what I call a single log equation. We have if the log base b of x equals the log base b of y, then the arguments x and y are equal to each other. These aren't too bad. Then the logs just completely go away. We don't have to worry about them, and we can just solve an algebraic equation. So, type 2. Okay, let's say that we have the log base 5 of x equals 3. Well, remember that logs and exponentials are inverses of each other, so we can rewrite this. If we think about an exponential, we need the base. Well, the base of the log is 5. Now the power, where's the exponent? The exponent, remember, is the log, what it equals, so 5 cubed, equals the argument, which is x. So we were able to convert our equation into 5 cubed equals x, and that's something we can solve. We can say that x equals 5 times 5 times 5, which is 125. So that's our second type of log problem. We have the single log problems, like this one, where we need to convert it. We convert to exponential form, and then we can solve it. So, two types. We're going to be looking for converting when we have a single log, and when we have a log equals log, we set our arguments equal to each other. So let's look at some examples. Haha, you're thinking, you lied to me. You said I was either going to have a log equals log or a single log. Well, that's true that we have lots of logs going on in this problem. However, we have some properties that we can use to simplify this and get one of those two situations. So the log base b of x, that's all by itself, so we can't really do anything here. But let's look on the right-hand side. Log base b, we can use properties. This is like saying the log base b of 4 times x minus 1. Because we're adding logs with a common base, we can multiply the arguments and write it as one log. Now we have a log equals log. Since these bases are the same, we can actually use this property that says the argument x equals the other argument, 4 times x minus 1. Now it's just a matter of using that algebra that we've been doing for ages. So we get x equals 4x minus 4. Move 4 over to the other side, so we get negative 3x equals negative 4. Divide both sides, and we get x equals 4/3. So that's our solution. Now we have to be careful with our logs, because we cannot have a negative argument. That's something we've talked about. So we need to look at our answer and look at our original problem and see if at any time an argument would be negative. So for log base b of x, that one's okay. And the log base b of x minus 1. Is 4/3 minus 1 still positive? Yes. So we're okay. Our answer is x equals 4/3. So let's try another one. here we have the log base 5. All of them are base 5. So we can use some properties, and then we can use one of those two solving techniques. I'm going to start with the left-hand side. It looks like I can combine these into one log. I have the log base 5 of x times x plus 2 equals the log base 5 of x plus 6. So yay! Again, this is a log equals log. I can set my arguments equal to each other. X times x plus 2 equals x plus 6. Okay, so we distribute. We get x squared plus 2x equals x plus 6. This is a quadratic. We are going to need to move everything to one side so we have equals 0. So we get x squared plus x minus 6 equals 0. And then we do one of the best, coolest, most wonderful things in the whole wide world. We factor. We need to think, what multiplies to be negative 6 and adds to be positive 1? We get positive 3 and negative 2. So when we solve using the zero product property, we end up with x equals negative 3, and we end up with x equals 2. Now remember, our argument needs to be positive, so we need to take all of these answers, look at all of the original logs, and see if we ever end up with a negative argument. I'm going to start with the negative 3. Log base 5 of x would be the log base 5 of negative 3. Oops, that's negative. So I automatically know that one's not going to work. Now let's look at x equals 2. Works in the first one, works in the second one, works in the third one. X equals 2 is the only solution we have. X equals negative 3 is an extraneous solution and cannot be possible in this particular situation because logs have some restrictions with them. So that one is extraneous. Alright, another log equation to solve. Another time I have to use my properties, and in this case it looks like I have common base of 2, so we can combine them. Yet again, we're multiplying. The log base 2 of x minus 2 times x plus 5 equals 3. This is a single log problem. I don't have log equals log. However, because it's single log, I can convert. I know the base, I know the power, and I know the argument, which is the equals to. So the base, 2, to the power of 3 equals x minus 2 times x plus 5. Now it's just a matter of using algebra. 2 cubed is 8 equals x squared plus 3x minus 10. Now since it's quadratic, we need to subtract 8 from both sides, so that will end up with 0 equals x squared plus 3x minus 18. And now it's a matter of factoring. Two numbers that multiply to be negative 18 and add to be 3. We know the bigger number has to be positive. So in this case, it's x plus 6 and x minus 3. So when we solve this, we end up with two solutions, x equals negative 6 and x equals 3. Sometimes both solutions work, sometimes neither of them work, but we need to check anyways. I'm going to start with x is negative 6. If we look at the first log, you end up with the log base 2 of negative 6 minus 2. Automatically, we know that one doesn't work. That one is extraneous. Now let's check on the 3. Sometimes neither of them work. The log base 2 of 3 minus 2, it's still positive. The log base 2 of 3 plus 5, positive. So x equals 3 is our solution to this log equation. Our log properties and solving with logs still hold for the natural logs. Remember, the natural log is when we have a base of e. So in this case, it would be the same as saying the log base e of x plus 2 and the log base e of x. So the bases are the same. So that means I can use a property. Looking on the left-hand side, this is finally something besides multiplying. The natural log of x plus 2 over x equals the natural log of 4. So we have a log equals a log. The bases are the same, so we can set our arguments equal to each other. X plus 2 over x equals 4. Now it's just a matter of using opposite operations and solving. I'm going to multiply by x. So we end up with x plus 2 equals 4x. Move the x over to the right-hand side. So we get 2 equals 3x. Divide both sides, and we are going to get x equals 2/3. Again, look up at your original problem. Make sure you don't have any negative arguments. 2/3 plus 2 is okay, and 2/3 is okay. So we have our solution. X equals 2/3 is the solution to that natural log equation. This log equation is very clearly a single log equation. But, what's the base? Remember, when we don't see the base written down, that's because it's the common base, which is 10. So if you don't see it, you want to think, oh, that means 10. So we can still convert it. We know what the base should be, we know what the power should be, and we know what the argument is. So we can say that 10 cubed equals 2w plus 8. Now it's algebra time. 10 times 10 times 10 is 1,000. Subtract 8 from both sides, you get 992 equals 2w. Now we can just divide both sides by 2. So we end up with w equals 496. Again, you got to check. Maybe we have some negatives going on up here, but we have 2 times w plus 8 in the argument. So I think we're fairly safe to say that w equals 496. Another log equation. Looks like we have another common base equation. So we can put some things together, use some properties, and then go ahead and try to solve. It looks like the messy side is the right-hand side. So when we use properties of logs, we're going to get the log of x minus 1 over x, because that's the difference of two logs. And then on the left-hand side, we still have the log of x plus 3. So we have a log equals log problem. We can set our arguments equal to each other. X plus 3 equals x minus 1 over x. And now it's just algebra time. Multiply through by x. Distribute. Since this is quadratic, we want to get equals 0. So I'm going to move the x and the negative 1. So we'll get x squared plus 2x plus 1 equals 0. And then we can factor. So we get x plus 1 times x plus 1 equals 0. So our two solutions are x equals negative 1 and x equals negative 1. Now we have to go back to that problem again. We have to plug them in. Well, negative 1 plus 3 works out okay. Negative 1 minus 1? Nope. That's going to get us a negative. So automatically we know that answer doesn't work. So we have no solution to this problem. We can just use the empty set if we want, or we can write out no solution. But there's no number that's going to make this log equation true. Last log equation we're going to look at, because we wanted to do another natural base. This is a single log problem, so we would need to convert. We need to convert it to exponential form. We need to know what the base is. Remember, with natural logs, the base is always e. So e to the 16 equals x plus 5. Our goal is to get x by itself, so don't worry about e to the 16 yet. We just need to subtract 5. So we'll say that x equals e to the 16 minus 5. E is just a number, so e to the power of 16 is just a really, really big number. So e to the negative 16 minus 5 is a number, and we can safely say that it will work in our arguments. X equals e to the 16 minus 5. We can leave our answer like that. So solving log equations, we have two cases. We have a log equals log, in which case we can set the arguments equal to each other. And then we have one like I have right here, which is a converting problem for when you have a single log. Both types of solving require us to use our properties though, so it's important for us to be familiar with those as well. At the end, you always need to check your solution to make sure none of your arguments end up being negative.